Hello. In class we were looking at our MP3 player or MPX player, and we went over an extension of the code, which this will be a review of. First, I'll play the thing, that is, run the program. Well, apparently my system doesn't want to quite cooperate at this moment and run the program. So we'll just pretend it's running. First part, what I'd like to do is have a menu. So here is some menu code. Menu code will display on the screen the word load, save, quit, play, tempo, the speed of the program. And the user will have a choice. Pick one. And then after the user picks one, we go to validate that character to make sure that it's either load, save, play, quit, speed, that he or she actually entered one of those values. So I have a function called validate. Give me your input character and give me a list of valid entries that are possible. If C exists in one of these, it will be true. Otherwise, no. Once that's done, we return a value C. So what does valid look like? It's up here. Valid is a function, returns true or false. We give it an input character, and we give it a vector, a constant vector, of characters. And it's direct access. So list, I call it list, is a reference to a vector of characters that are constant. All right, just check the list for valid choices. Fix a little typo there. All right, C++ allows us to take our vector, take out one element at a time, that is a character, look at that character and compare it to the character here, C. If they're equal, that means it was in the valid list, so I return true. If going through the entire vector, we find no matches, then we return false. That is, C was not a valid in this list. And this is a very nice piece of code. I don't have to write a complex if statement down here, a conditional. Okay. That's our menu. Very nice. What do we use this menu for? Well, let's go down a bit and take a look further down. Here is our main, short and sweet. Choice. Go to our menu, find out what we want done. Execute our choice. Well, we told we were quitting. If we're not quitting, we go back up, get another choice from the menu, execute that choice. What were our choices? Our choices were load, save, quit, play, speed. That is this tempo. Great. So let's go down to execute. Execute. Tell me what your choice was. I changed that, I like the word command a lot better. All right, so give me your choice. If it was quit, I'll just say goodbye. You can do a lot more. If the choice was load a file, I'm going to ask the person, get me the name of that file. I'll put the extension on the end of it and our current path. That'll be the new file name. And I'll use a function called MPX, load. MPX, well, that's our branding of the load function. Give me the name of a file. It'll load it with a song. Great. What if I said save? If my choice was save, again, what do you want to name the thing? Get the name of the file you want to save it as. Add MPX extension to it. Add the path. Call our name brand MPX save API or interface. Give it the name of the file. Give it the song, and it will save the song for us. Great. Now I want to play it. To play the song, I just have to give MPX player our song. Speed. Well, first thing we need to do is find out how we want to change the speed. Fast, speed it up, slow it down, enter the number, call our MPX tempo program for speed, take the speed S and apply it to that song. And we could add more choices like that. Choice and action. Choice, action. Choice, action. choice, action, choice, action. It's a very nice paradigm, and you can build things. You can add more and more choices and actions. I called it the execution unit or execution code. CPUs and interpreters work pretty much the same way. All right, here's our get a file. Get a file is, it automatically will take this star, this is a wildcard, find anything that ends with MPX and show all files that end with MPX. The user will see it and enter the name of a file. We get the name of that file and return it. And that ends our main program. Next, we're done pretty much. These are some details. Clear the screen. Clear the screen, you pass this thing called CLS to my system as a message, and the window console will clear the screen. This is particular to Windows. Next, this is particular to Windows. In Unix, you would say ls. But in Windows, you say directory /b means show me the bare bones listing, but only show me things, in this case, that have ms, with a message on the end, which was this. Show me things that end with MPX. Next, what I'd like you guys to think about once you get it working, to add some more things to it, like about, the about box. Help me, what's this program doing? We go up a little further, I have our global variables. Here's our song. All our songs go here. Here is for my computer the path for our Little Lamb version 2 directory. Notice slashes have to appear // because remember, you can do things like this. If you said /n, that would mean a new line. If I had a /l, that would be L. So I need a // to get a slash. This means one slash. Then I have no file name chosen, and I have an extension. Always end with a .mpx, and that's the name extension. Next, I have all my commands. Load, save, quit, speed. You could put numbers in here too. In class, we use the number 1, the number 2, the number 3, but I think letters have more meaning to me than numbers. And speed, I think I decided to change it to tempo. So let's go up and take a look at our program. Here's the one to save. Give me the name of a file and give me a song. What is song? It's a vector of notes. Open up that file. If I can't open the file, tell me I can't open it, then crash and burn. You might just do a simple return, do nothing, instead of crashing and burning. Next, how long is the song? Put that at the top of our file, and then take the data, one note at a time from our song, put it in X, don't change it. This is X, is a reference, and here it's automatic, but it's actually a note. Notice my compiler doesn't complain, but I'm going to let C++ handle it for me. C++ will infer, doesn't guess, it infers what X should be, and it's easy enough. What is song? Song is filled with notes. So that means every time I pull something out of song, it's going to be a note. All right, so I pulled a note from song. I'm not allowed to change it. I said, go inside that note and get its frequency. Go inside that note and get its duration. Send both of them to the file and then skip a line. Why? Because it looks good skipping a line. Here's one of our songs. Here's the original Mary MPX. Notice at the top, it has the number of these things we called notes. So here's a pair, another pair. This is our song, one note at a time. And this is saving it. When it's done writing all the files out, we then close up the file. Notice the song has been unharmed. In fact, we should probably put const there to stop someone from accidentally at 3 o'clock in the morning saying, I wonder if this is really working. Why don't we clear this thing out? We don't want anything like that to happen, so we put const there. Watch. I took away constant, and now I can do this. This thing can happen by accident. I put the word const. I can't accidentally wipe it out at 3 in the morning. So this will save it. Save it where? Any file name that it's given, or at least it will try and do it. If it can't, it will crash and burn, or you could just say return. It'll do nothing. Your homework will be to change the tempo and the actually frequency. So here we have the speed. So it gives me a vector. Notice I didn't put const in front because we want to change it. Now, how do we want to change it? We want to make the duration either longer or shorter for each note. So we go into the song, pull out one of the pieces of data. Notice it doesn't say constant here anymore because I do want to change it. So this says X is a reference to a note that's inside song. Take note X, take its duration, and times it by factor and update duration. You should do the same thing for pitch, where instead of changing duration, you increase or decrease the frequency. Here's our player. Give me a song. Pull one note out at a time. Don't change it, and use our beeping function to just go beep. Remember, the actual beep only works with Windows. In anything else, you'll probably just have to just see the numbers flash before the screen. Next, load a song. Load's a little more complex. What file do you want to go in? Give me the place that you want to store the song. Open up the file. Crash and burn if you can't find it. Now we want to actually clear the song. In case somebody had an old song, we want the vector to be wiped clean, so any previous song is removed. Next, go in the file, get the first number. And what first number? This. That's N, our first number. Next, since we know what N is, we can then run a loop, pulling out from the song each pair of notes, F and T, frequency and time, and then pushing back into the song, push back into the song, a note filled with whatever the number F and whatever T is. That will be pushed at the end of song. When this loop is finished, we close out our file and we return. Pretty much that's it. This is some wrapper code because beep only works with Windows. And here I have a link for documentation you can search. Give me F, give me T, and it will use the beep. And beep returns either true or false. I think it always returns true. Unless, of course, it doesn't make a beep sound. Something went wrong. So my beep is really the original beep. Next, my system says this is a system program that goes to the console. It's an old API. It needs a C string. So, and this thing only works with Windows. So what I do is I wrap it up, and this allows me to do stuff like this. I can say cout. I can leave this blank. If we're using, using a Mac, you might want to blank this out. And in class, I believe we went over how to compile based on environments using the preprocessor. But for us, just comment it out. And at the very top now, we see our note. Got some comments here about the frequency and the time duration. And I would show you it working, but for some reason, every time I try to get this thing to work, it just goes into some weird position. All right, hope you enjoyed that. Again, this is a review from things we've talked about. this is on Blackboard, all the code that for you to play around with. And for your homework is when you get the code, add this program and add this. Later we'll modify this again to make it cleaner and maybe even more powerful. Thank you.